All right, this is the cybersecurity career simulation number one. I am Zach Barron. For this project, I had to install a firewall, a CEO's PC, internal web server, and DNS server, as well as 3 Linux machines for monitoring and conducting cybersecurity tasks. I documented configurations and create security baseline by scanning open ports, describe the services performed, describe network problems and their solutions. I will give security recommendations and finally closing remarks. What I've done for this, I've installed and set up new virtual machines, configured the network and tested connectivity, documented all configurations for PCs and servers, ran a scan of open ports during a file transfer, and analyzed the network scan for security vulnerabilities. The first task was to download VirtualBox and the extensions and 7 virtual machines, including a router firewall, web server, DNS server, CEO PC, and 3 Linux machines. And to make sure that they were all functional and working correctly. The next task was to access a web page on the CEO's PC, which failed initially as the computer was misconfigured to a manual a static IP address. So I had changed the configuration to an automatic DHCP and reset the network, and then was able to confirm that the computer was connected to the internet and had internet access by going to the seclab.net webpage. Task 4 was documenting the OS, IP address, subnet mask, default gateway address, and DNS server address that you can all see here. The CEO's PC is running on CentOS release 6.4. Its IP is 192.168.0.15 /24 is the prefix. The default gateways 192.168.0.255, DNS server 10.200.0.11. And then we've got same thing, but for the web server, DNS server. These are running off of Ubuntu 8.04 as an operating system. The web server's IP address was 10.200.0.12. The default gateway for both of them is 10.200.0.15. DNS server for both 10.200.0.11. This will come in later, but they have several open TCP ports that I'll discuss later. IP address for the DNS server again was 10.200.0.11/29. The next task was to transfer a file through FTP using TCP port 21. As you can see through the screenshot, I was able to log into FTP and find and download the social media security policy through TCP 21 FTP. The next task was to create a new user and password for the web server, which you can see is in the screenshot here at the bottom. Sudo ID, user add Zach to sudo ID Zach just to confirm that it was added, and then sudo pass wd Zach to create a new password. The next task was to use nmap to document open ports. Here's the open ports on the DNS server, 10.200.0.11. They only have 22 and 53 open. And then on the web server, there are a little over a dozen, several TCP ports that are open that you can see here: 21, 22, 23, 25, 53, 80, 111, 139, 445, 512, 513, 514, 1099, 15, 24, 2049, 21, 21, 33, 06, 54, 32, 5900, 6000, 66, 67, 80, 09, and 81, 88, all open. As you can see, the final task was to capture traffic from this from the FTP transfer we had earlier. I actually did an additional one and downloaded the other file that was in that folder. As you can see here, you can easily read in plain text the username Jasper and the password too hard to guess, which shows a clear security vulnerability that you can read usernames and passwords in plain text through FTP. So security recommendations for this: close off insecure and unnecessary ports, including port 21 FTP, and use a more secure method of file transfer, such as secure shell, or one of the other options through port 22 uses secure shell. In conclusion, I set up the network, verified functionality and connectivity. I documented the configurations, and I scanned and analyzed for security vulnerabilities. Thank you.